95% of enterprise AI prototypes never make it to production. You need agentic operations to match agentic engineering. Nothing emerges fully formed, and so you've got to have the patience to work with it.
Welcome to the Enterprise Thought Leadership Podcast, where we explore the latest in enterprise trends, tech, and strategy with the top leaders shaping the future.
Welcome to Enterprise Unlocked. I'm your host, Radhika Mukherjee, Editor-in-Chief of TalkDev. Our guest today is Phillip Merrick, co-founder, Chief Product Officer, and Chairman of the Board at pgEdge. Phillip is a technologist and entrepreneur with over 3 decades of experience. He has co-founded and run successful companies such as WebMethods, Enterprise DB, SparkPost, and Fugue. Welcome to the podcast, Phillip.
It's fantastic to be with you. Thanks so much, Radhika.
Thank you. It's wonderful to be here with you today, and I'm sure it's going to be just such an interesting conversation.
Well, we'll see.
So let's set the stage then. While many enterprises are now actively scaling AI projects, most fail after the prototype stage. According to Deloitte, even for agentic AI, only about 11% of enterprises have deployed it, especially in production. This is a significant gap. Phillip, you have experienced multiple technology shifts in your career. Tell us about the learnings that will help developers today.
Yeah, delighted to, at least in terms of my own experience. So some caveats, your mileage may vary. But to talk first about that gap between prototype and production, it's very real. You cited a survey. There's one that went viral toward the end of last year from MIT that says 95% of enterprise AI prototypes never make it to production. There are a number of surveys pointing to this. It's definitely happening. We see it in organizations that we work with. But first of all, to be fair and to put that number in some perspective, we're talking about prototypes, and the idea of a prototype is you are actually trying something, and so inevitably some of those are going to fail almost by design. So it's a little bit unfair to say, oh, hey, lots of AI prototypes fail. It's like, well, particularly with agentic AI, you're trying a whole bunch of different things, maybe in parallel. Which one works the best? Let's go with that one. So I think that's a little bit of a caveat. But the other thing I'd say is there is definitely a very real drop-off, and it's not just because we're playing natural selection on our prototypes. It is true that a lot of AI applications where the owners of those applications that they've developed in prototype would love to see them get put into production, but they can't. We've talked to CIOs who say, hey, we've got a whole bunch of AI prototypes where the business owners dearly want to get them into production because they see a lot of business value with them, but in their current form, we can't let that happen. Why can't we let that happen? It's because those prototypes have to run in highly compliant, secure environments, okay? And that's going to be, maybe it's in the cloud, but it's a tightly managed, compliant cloud account. For a government customer, it might be in GovCloud or whichever vendor's GovCloud. It is most certainly going to be a very locked down environment, and it's under the enterprise's control. It's not under a vendor's control. The other deployment model is on premises, of course, and some applications have to run on premises. They just do. We can argue that, but that's the state still. And if anything, there's a sort of a turn back to on-premise for various reasons, including cloud costs and the ability to run models locally and data sovereignty and all of those things, which we could get into later if you wanted to. But all that to say is like the infrastructure has to be compliant, secure. It has to be the enterprise's infrastructure, and the prototypes are developed on these wonderful platforms. if you look at some of the AI builders like Lovable, which is great for non-technical users, and like somebody with no programming experience whatsoever can rapidly develop an application, and it's like, this is great, it does exactly what I want. Yeah, but it's doing it in a proprietary vendor-managed cloud environment. We can't let our data go up to that environment, okay? So unless we can re-platform that to our compliant infrastructure, it can't happen. So that, we think, is one of the very big reasons why prototypes aren't making it into production. Then some of the database environments are just running in vendor-managed cloud environments. Again, same thing. The enterprise data can't be allowed to go up there, and the app can't run there in the first place because they're PCI compliant, FedRAMP, whatever it is, right? Or just their own security and audit controls. So that's a big factor. The other factor is we've had a lot of success with agentic engineering, and in the last 12 to 18 months made our developers 5 times more productive in generating code and producing code. That's awesome. But there hasn't been a step up in what we might call agentic operations, the ability to actually administer and run all those databases for those applications. So think about your poor DBAs, right? They're already struggling to keep up running the databases that you already have. And these agentic applications come along and generate tons more databases that have to manage. And so you need agentic operations to match agentic engineering. So number one is you need flexible infrastructure choices. You need the ability to target your applications to your production infrastructure. That's a big piece that's missing. And then you need to be able to turbocharge your DBAs with agentic operations capabilities. And so those two things, dealing with that production gap on the infrastructure and agentic operations, that's a big focus for us here at pgEdge, and we're really proud of some of the things that we've been putting out, which is all open source. It's all there on GitHub, or you can go get the binaries from us. But anyway, the second part of your question was sort of trying to put this in a historical context. There's always this inclination to say, well, no, this time it's really different, and all those lessons don't apply. And I get with AI, there's a lot that's really different. But there are, what was it that Mark Twain said? History never repeats, but it rhymes, right? So some of the same themes resonate. And what I see, what I am most reminded of is sort of in the original web revolution, on the back end of that, we realized that we didn't just want to connect people with information and data, but we wanted to connect servers together so servers could exchange information over the web. And this was the genesis of the web services and web API idea, which we pioneered at Web Methods. It actually turned out we were the first to really get out there with web services, although they were some people at the patent office actually spent 10 years looking into this because we had a patent application for this. They gave it to us after 10 years. There were other groups who did bring things to market, but it actually turned out we'd done it first. But in the web services world, we wanted to have a set of standards. You needed a set of standards to govern the exchange of information, and that was great. We started with some basic standards like SOAP and WSDL, which our company worked with Microsoft and others on. But then it just exploded. People went crazy and they started developing web services specifications for a bazillion different things. And the whole thing kind of collapsed under its own weight. And then somebody came along and said, hey, why don't we just go back to doing this the simple way? And that's where REST web services sort of came from. But there was a period of 4 or 5 years where people were suffering under the weight of all these different specs and all the complexity of it, when it was actually a very simple thing at its core. And if we're not careful, we could see that happening within particular the MCP family of standards, it is fantastic that we've agreed that Model Context Protocol is the way that agents and LLMs will interact with the outside world, will interact with other software applications, and will interact with, in particular, databases, right? It's great that that's been standardized, but already we're starting to add to that. So, for the folks who are involved in those efforts, I just say, look at what happened with the original web services standards, and don't let this thing collapse under the weight of its own complexity, because it's actually started out pretty simple and good, and it would be fantastic if it could actually stay that way while still extending it for new capabilities. So you might have seen that there's now an extension to the MCP specification for actually doing apps, doing app UIs inside of agents and LLMs, which is actually pretty cool. But anyway, you hit me there with two very big questions that unfortunately didn't, at least in my telling of it, didn't have short answers.
That's totally fine. I think that's why we have the podcast format, which is great. Great for long conversations, and it's really great to go into detail. So thank you for that, actually. So just to kind of draw a conclusion from this, the technicalities seem different, but I think the mindset is something that we can maybe draw wisdom from the past from. Is that the right interpretation?
Yeah, I think so. I think the tendency sometimes when radically new things come along is to say, oh, well, that's not going to work. That's not going to scale. So I remember back when we were telling people, it's like, hey, we can actually use HTTP as the protocol for data exchange, period. I was like, no, that won't work. That's, people at Gartner said, no, that's crazy. Nobody's, it's a brittle protocol. Nobody's gonna trust it. Okay. And now, what does every API run on? It's like HTTP, right?
Yeah.
So, okay. So, but people were kind of closed to that. It's not going to scale. It's not going to be secure enough. It's not going to be this. It's not going to be that. And you saw that kind of like knee-jerk rejection of the AI coding assistants initially. It's like, well, this is just making it much harder to get my job done. I spend more time fixing the code. Right? But then I think once the models got better, that broke down the resistance big time, and now you'd be hard pressed to find engineers who are not using agentic engineering tools.
Yeah.
So I'd say having an open mind and being willing to try things, like, nothing emerges fully formed. And so you've got to have the patience to work with it. And, you can actually sometimes be part of the community that makes it performant, makes it secure, right?
Yeah. It's that creative mindset and maybe creator mindset that I think has become even more important than before.
Absolutely.
Yeah.
Absolutely.
Yes. And from what I gather, development used to be more deterministic. It's now more probabilistic. So how can developers really upskill themselves to take advantage of the shift? How do they work with these probabilistic systems well?
Yeah. Well, you think about it, humans are used to, in our conversations with each other, saying the expression, it depends, when asked a complicated question. But we used to be able to rely on the computer and algorithms to not give us it depends kinds of answers. Now they do, and sometimes it just depends on when you ran the query. You might get slightly different answers. So it's really interesting. It's like, so the way I think about it in a couple of ways. So it's like, hey, if we can get this agent that maybe does some workflow for us. Maybe we're doing claims processing in an insurance company or something like that, and we can get the agent to make the right decision 95% of the time. Some people might say, "Oh, that's horrible. It's got to be like 99.99%, or it's got to be 100%." It's like, well, wait. How accurate is the human doing that today, right? So that's the first thing to think about it. The second is, as we're building agents, we might be, and we are tempted. I've certainly done this when I've been building my own agents. It's like, hey, I've got this task. It's got like multiple steps. I'm just going to have my one agent work through all those steps. And so, as I write out the English spec for the agent, I'm going to write out those steps and tell it to go do those steps one at a time. Well, the problem is, like, if the probability of getting the first step right was 95%, but then it was 95% on the second one, and maybe it was only 75% on the third one, like, so those multiply out to like a not great probability at the end. So if you've got a complex agent trying to do multiple steps, then you're going to be disappointed. The agent's going to do the wrong thing a lot of the time. But if you thought about it a different way and said, hey, instead of having a big monolithic agent with 5 steps, how about I have 5 agents that cooperate with 1 step each, and they each do one thing well, okay? And so each of them has a 95. So instead of it being a low probability that the whole thing gets done correctly, it's a much higher probability. You get a much better result if you chain a bunch of agents together instead of doing it monolithically. And I think that's something that developers really have to get their head around. And one of our fantastic engineers, Sean Thomas, actually wrote a blog about this in the last week, talking about how we really need to take what is and this is getting inspired by lessons of the past, take that Unix systems philosophy of building utilities that just do one thing, do it well, and then chain them together in a data pipeline. And if you sort of think about classic Unix and like all those little utilities that it's like, hey, you have WC to do word count, and that's all it does. It just counts words. And then you have a pretty printer, and you have grep, and it searches for strings and regular expressions, and that's all it does. And that each one of those things doesn't do anything like what you want to get done in your work, but chain them together in a Unix pipeline, and you've got something that does the job, and it does it very well, and everything is nice and simple and understandable, instead of being a big ugly monolith that's really hard for humans to comprehend. So like taking that Unix design philosophy into your agent design philosophy is, we think, a good way of addressing that problem of, oh my gosh, it's probabilistic now, it's not deterministic.
Yeah, wow. That's a great practical solution. What are some other practical strategies that can help developers bridge this gap we've been talking about between prototype and production?
Yeah, so first thing is think about, design with the end in mind. So you want this to go to production. What does production look like in your organization? I think the great thing that's happened in software development in organizations over the last 15 odd years, 20 years maybe, is that we've empowered developers to choose their own tools, within some constraints, but with that freedom comes responsibility. And yes, you can go prototype in one of these cloud environments, but design with the end in mind. Like, how do you get that to production? So if you're going to go prototype in one of those environments, how are you going to get it to your compliant infrastructure. And one of the things we're doing is we're working with some of those agentic engineering code generators to take the outputs, the code outputs of those, and provide tooling to easily re-platform to another environment, particularly pgEdge.
Okay, all right. Let's shift a little bit to data, right? So, does the strength of the underlying data infrastructure impact the success of AI projects, especially in the enterprise context?
Oh, absolutely. The data is just key. So those who saw Jensen Huang's keynote at the NVIDIA developer conference recently will remember that he said very pointedly that structured data is the ground truth for AI. Like, without reference to the enterprise's data, what are the AIs and agents going to do? They're going to go hallucinate stuff, right? That's what they do. Unless you say, here is the data. And actually, sometimes you actually say that in the prompt. It's like, the data is in this database over here. Make sure you use MCP to go access that and don't make it up. I've literally used that kind of prompt in one of my applications. It's like, don't go making this up. The data's there, just go use it. Here are some MCP tools to get to it. So the data is absolutely key. We think, we could be biased, but a lot of the world agrees with us now. The best place for that data is Postgres. It's not just where you can, it's not just the database for running your transactional systems, which is traditionally how people have thought about Postgres, but it's a great way of federating access to all your data sources, because Postgres has a number of wonderful extensibility mechanisms, one of which is, the first one is the extensions capability, which allows you to literally extend what Postgres can do. If you want to add another column type, like say vectors, you can create an extension like pgvector to do vectors, which is great. But the other way you can extend Postgres so that you can federate data access across your enterprise is using something called foreign data wrappers, where you can make an external data source just look like Postgres tables and then access it like Postgres tables. So you can then use that to centralize and manage access to all the data sources across your enterprise, and that includes data warehouses as well. There's a wonderful open source software called DuckDB, which does a great job of helping you interface between Postgres databases and then data warehouses that are built and managed with Apache Iceberg. So Postgres is, there's a joke among developers these days, which is just use Postgres, and so we're big believers in that, and hopefully for our customers, big enablers of it.
Yeah. It also sounds like the decisions that you really take in laying out your data and structuring your data are the most important aspects. So the question I have is, how do database decisions determine whether AI projects scale, especially enterprise AI projects?
Yeah. So coming back to choice of database and where it resides, those are the big considerations. So I just made my pitch for just use Postgres because it's the easiest way to get access to everything, right? But then there's a question of what Postgres and where does it reside, and obviously I've got my pgEdge shirt on, so we'd love for it to be pgEdge, but the practical consideration is, if you're prototyping in a cloud environment that's vendor managed, is it permissible for you to get your enterprise data up there? Is it possible to go into production in that vendor managed cloud platform? And I'm talking about things like Supabase and Neon, which are absolutely fine products and great for developers. But they have this limitation that it's running up there in the cloud. So maybe your enterprise isn't so tightly regulated and locked down, and you can do that. But when you start your prototyping, it's like, hey, can I actually go to production in this environment? No. Well, it doesn't mean I can't use it. Well, that's probably up to the policies of your organization, and you want to make sure you know what they are when it comes to using these tools. But assuming you can do your prototyping up there, it could be perfectly valid to prototype there, but you've got to have a strategy to get that migrated and re-platformed. We personally think it's better to just start off on the same platform, the same Postgres platform, and actually have that carry through. So your Postgres platform needs to have flexible deployment options. Okay, so vendor managed cloud, what some people would call shared tenant infrastructure, shared multi-tenant infrastructure. Sorry. Then BYO cloud for those tightly managed enterprise cloud environments we were talking about earlier. So do that with BYO cloud. And then on-prem. Does it support on-prem if you have to go on-prem? And then for extra credit, if you're really in a secure organization, maybe you're running air-gapped. We've got customers who have to deploy everything in an air-gapped environment. So fortunately for them, they can do local models, and the pgEdge Enterprise Postgres platform goes all the way from cloud environments all the way through to on-prem and air-gapped. So understand the constraints that a production application has, understand the constraints that your enterprise data has in terms of where it can live, and then make sure you've got a strategy to get from prototype to production. So the number one thing that these failed prototypes likely suffer from is there was no plan to get to production. There was just hope.
Okay, so a proper plan, especially with the help of something like Postgres, very important.
Yeah. So some of our colleagues in sales are familiar with the famous sales book, Hope is Not a Strategy. I think it applies here as well.
For sure. Is it a function of this being very new? Is that the hold up, do you think?
Yeah, sure. I mean, I think whenever you've got something relatively new, people are just going to be trying lots of things and sometimes getting their fingers burned. But they learn, and if they're smart, they're not going to do that again. Maybe it depends on how you like to go about your professional life. If you want to just try all the things and see what burns your fingers, go for it. Alternatively, you could put a little bit of thought and planning into it, and maybe have a better success rate.
Yeah. I definitely believe in the second philosophy for sure. But maybe fail fast is also one way to go.
Sure.
I'm not sure.
Sure.
Yeah.
And in the right context, there's nothing wrong with that. But maybe in a regulated enterprise, fail fast is not too good.
Yeah. Absolutely. So let's go back to Postgres. I think I'd like to hear a little bit more about it. So, just asking like a what do you call it? A very formal question. What's the role of open source databases, particularly Postgres, in creating successful agentic AI systems?
Oh, wow. Yeah, that's a great one. So, what's funny about Postgres is it's the most modern 30-year-old open source database out there. And there's that paradox of like, we think of it as being very modern, but it just celebrated its 30th birthday. The Postgres community had a nice birthday party up in Vancouver at the Postgres Developers Conference.
So it's a millennial, is it?
Yeah, so it's a millennial. Yeah, there you go. Somebody's going to grab that and use it. So the thing that makes Postgres so great, and why developers love it, and now why agents get along so well with it, is it's a very beautiful, straightforward, extensible architecture. So we talked about that a little while ago. There's nothing that Postgres can't do. There's nothing in the data world that Postgres can't do. It's just that maybe it hasn't done it yet. And if it hasn't done it yet, we can develop a standard extension, which we then plug into Postgres with this standard pluggable extensions architecture. And now it can do it. So a couple of years ago, everybody was talking about how we were all going to be using these proprietary special purpose vector databases to store our vector embeddings. Hardly anybody does that anymore. What do? Well, they store it in Postgres because some wonderful engineers developed pgvector to store vector embeddings in Postgres itself. And it's like, which is great because where is the data that the vector embeddings are representing? Well, it's right there in your Postgres database. So why not have the vector embeddings right there next to the data? And then you say, wait, what do I do when that data actually changes? Because I've got to change my vector embed. Every time the underlying data changes, I've got to go create a new vector embedding for the new data. And that's kind of tedious. And it's like, yeah, it's tedious. Well, guess what? There's an extension for that. So our engineers developed something called pgEdge Vectorizer as an open source extension. It's there on our GitHub. You can go get it. And pgEdge Vectorizer uses pgvector under the covers to go create vector embeddings for your data. And then automatically, as the data changes, it updates those vectors. So you now don't have to think about managing your embeddings at all. It's we all love that expression that Apple popularized with the App Store. There's an app for that. Well, in Postgres, there's an extension for that. And if there isn't, well, guess what? You can go write it. And then you can go post it on GitHub. And if people love it, then it becomes part of the overall Postgres ecosystem. That is, I think, the biggest reason developers love Postgres. And also it's just very easy and logical to work with. And it'll store absolutely anything, just about. So geospatial data through the PostGIS extension. For the longest time, Postgres didn't store native JSON data, but that was fixed many, many years ago. So the fact that it couldn't store, it couldn't be used as a document database, and it couldn't store documents easily, and it couldn't store, in particular, JSON documents, right? That was a big reason why developers took a left turn 10 years ago and NoSQL databases became very, very popular. Well, Postgres adds the document support, the JSON support, and guess what? Now you can just use Postgres.
Wow. It's an all-in-one solution, it seems.
Exactly.
Yeah.
And if it's not, just create an extension.
Wow. Yeah. And that's the beauty of open source, right? There's so much you can do.
Yeah. And actually, I'm glad you raised that, because that's you've got me talking about just one of my favorite things ever. But and that's the Postgres database. But And then, pgEdge is actually my second Postgres company that I've co-founded, Enterprise DB being the first, many, many years ago. But the fantastic thing is that it really can be used for just about anything you might imagine. And we haven't even talked about stored procedures and functions and like all of those things. But you mentioned open source, right? It is fully open source. It's open source under the Postgres license, which is an OSI approved license, right? So OSI say, this is pure open source, this is not pure open source, right? Based on, are there any restrictions in the license? So there are no restrictions in the license. So you can do anything you want with that open source Postgres and anything else that uses the Postgres license. So, number one, there's no vendor lock-in. Number two, and this is an important differentiator when we talk about open source, there are two kinds of open source. There's community owned and driven open source, and then there's single vendor owned and driven. So if you think back to, well, you don't have to think back, it's still with us. MySQL was the product of one company, and that company was the MySQL company. And they owned it and they got to control it. And so even though it was open source, there was still, there was some vendor lock-in there, and you got tied to that company. And then Oracle bought them through Sun, and now Oracle controls MySQL. There is no company at all that controls Postgres. It's the community working together in a very collaborative way. And I think, kudos to the pioneers of the Postgres community, some of whom are still actively working on it. In particular, Bruce Momgen, who's been doing this for the better part of, I think, 30 years. Dave Page, our VP of Engineering at pgEdge, he's been part of this for at least 20 years, probably longer. So you've got this core team that overall manages the project, and it's 7 people. Bruce is one, Dave is another, and then a broader group of the committers and contributors. And you look at where these people work, and it's AWS and Google and Microsoft and pgEdge and Enterprise DB. It's a whole bunch of vendors who compete with each other, but we all collaborate on this community open source project. So no vendor lock-in, right? So you choose Postgres, you're not getting tied to a vendor who's going to try and, extract a whole bunch more money out of you next year as they, raise the license fees yet again.
Yeah. We've been having a lot of these conversations, and I think we've have a brilliant article up on TalkDev by Kat Cosgrove that talks about the kind of responsibilities that developers and enterprises have towards open source as well. That as much as you benefit from it, you have to nurture that space as well. You have to give back in certain ways as well. I found it absolutely fascinating.
That's an important thing that you just mentioned there, the give back piece, which I think some companies forget or choose to forget, and it doesn't work unless people do give back and are willing to be willing to have the same mindset as the people that have made this software available in the first place. In the Postgres community, we just had a very dramatic illustration of this and how it can work, but also it was a warning as to how things might not work if companies don't step up. So one of the best ways of backing up and restoring a Postgres database is an open source piece of software called pgBackrest, which is a great name. And many companies in the Postgres ecosystem, vendors and end users alike, love it and have made use of it for years and years and years. Developed by one guy, largely. A little bit of help, but mostly one guy. A few months ago, he was out looking for somebody to sort of provide a home for him and the pgBackrest work. That didn't work out for various reasons. And so, quite rightly, he said, hey, after 12, 15 years, whatever it's been, I reluctantly have to shut down this project because I can't do it anymore. It's not financially viable for me to continue spending all my time on this. I need some support for this. I couldn't find the support. And so what happened was the community rallied, and a number of us said, hey, didn't realize it was quite that bad, and we love this software, our customers love this software, we really need to keep it going, what can we do to help? And shame on us for not doing this sooner, all of us, but I was very proud that pgEdge stepped up to support pgBackrest and its author, David. Then a couple of other companies as well, Superbase, Pacona, we all stepped up and we put that project on a firm footing now, so we can all continue to get the benefits of the great work that's gone into pgBackrest over the years.
Wow.
But you can imagine how that horrified people. It was like, wait, I rely on that for my backups of my databases, and you're saying it's just not going to be maintained anymore? Ouch.
Yeah. So it's both a very inspiring but also very practical story, right? That it was so necessary and then the community rallied. That's amazing.
Yeah. I mean, there's a what is it, XKCD comic that geeks love, me being one of them. And the one I'm thinking of is like, it's, I don't know if you remember this, there's like this building block contraption that is very complex and very convoluted, and it all rests on one tiny piece, and the caption, is an arrow to that, and the caption is critical piece of software being developed, being maintained by a single guy in Idaho since 2005, right? And so we had a very vivid illustration of what happens, or what might happen if you go pull that block out.
Yeah, like pulling that block out of the Jenga.
Yeah, exactly.
Yeah. My God, yes. Amazing. So that was very inspiring, and it really ties a bow around the whole open source movement and how vital it is, really. I'd like to also, to wrap up our conversation and tie a bow around it, I'd like to ask you, what are some overall guidelines you'd suggest to enterprises to help with, successful AI deployments, maybe not just in dev, but even across departments, that how should the entire cycle work, and just as an overview, maybe?
Yeah. So I'll come back to something I said earlier, which is design with the end in mind. So if this is not going to be a throwaway prototype, it is something potentially you want to take to production, then understand what it will take ahead of time to get it to production. So what are the security, compliance, and governance requirements that need to be applied to this in production? Also, how is it going to run in production? Do you need any more resources? Do you need agents to go manage the agents, right? Do you need agentic operations to help manage the complexity of that application running in production. Maybe yes, maybe no. But the critical thing is really understanding the requirements for it to be in production. What does that look like? What security requirements? What compliance requirements? What governance requirements? And then make sure that in the development of that application, you're paying attention to them, and it has to be a through line that goes through the whole stack, goes across the whole stack. So where are your governance guardrails in your MCP servers and in your agents and your code and your prompts? And it's like, what have you done to architect in those guardrails that are going to keep you on the straight and narrow when it comes to those requirements? Because before that application goes to production in any decent sized enterprise, you're going to have the CISO and the compliance folks, or at least people who work for the CISO, giving it the once over and the twice over and the thrice over to get confidence, right? And oh, by the way, if some of those tools that you use to build it, or that are part of the runtime, like an MCP server, if those things are not open source, then you can't really trust it, because you cannot see what that through line is on the governance guardrails. So that would be my kind of parting advice on what you can do to maximize the chances of success, and make sure that your AI prototype doesn't end up as roadkill on the roadside.
Yeah. Hopefully this will give rise to many, many successful production-ready AI programs, hopefully.
Hopefully, yeah. Whenever I'm giving out advice to folks, I'll usually say, well, it's quite possible that this was worth as much as you paid for it.
Sure it was. This was just such an amazing conversation, Philip. It was an absolute masterclass, and I'm sure our audience will be hugely benefited from this. Thank you so much, and thank you for joining us on Enterprise Unlocked.
It has been my pleasure and a lot of fun. Thank you so much for giving me the opportunity.
Thank you. Appreciate it. And of course, to our audience, thank you for tuning in, and keep listening to Enterprise Unlocked. Thank you.
Thank you for joining us for the Enterprise Thought Leadership Podcast. Please do follow us on social media and subscribe for more ideas and insights. Until next time.